John McGill is a firefighter with the Slippery Rock Volunteer Fire Company and Rescue Team. 17 years ago, he and a fellow firefighter were on their way to a call when the GMC Brigadier tanker they were riding in rolled over and crashed. The driver suffered a broken shoulder, but John had more permanent injuries.
We're going out the road and we lost control of the truck and it started to go broadside and we hit a telephone pole, and next thing I remember, we're on the side. From the accident, the injuries I received was a C6 spinal cord injury and facial cuts. And then I'm paralyzed from the chest down, and I have pretty good use of my arms and limited use of my hands, and I think I do pretty well for what I thought I was going to end up with.
There's a sad irony to John's story. The crash that left him paralyzed occurred just 5 days before his first wedding anniversary. Here's the thing you ought to know. John's rollover crash, like all rollovers, could have been prevented. And in this presentation, we'll show you how. Nationwide, the number of rollovers involving emergency vehicles has skyrocketed in the last few years. A large majority of those accidents were single vehicle crashes. So what's going on? Well, according to NIOSH investigations and a USFA white paper report on the subject, the cause of most rollovers is driver error. That means you. There may be many factors that contribute to a rollover crash. Wet roads, poor visibility, too many distracting voices on the radio. But it all comes down to you. Now, here are 3 key things to keep in mind. Excessive relative speed is a common reason rollovers occur. Many fatalities and serious injuries can be avoided if the occupants are wearing their seatbelts. Neither John nor the driver of the tanker had their seatbelts on. Both fire and EMS vehicles are commonly involved in rollover crashes, in particular tankers, pumper tankers, ambulances, and aerial apparatus. In this program, we're going to take all the components involved in a rollover crash and break them down for you. We'll look at you, your vehicle, common rollover circumstances, the physical dynamics of vehicle operations, and the mechanics of vehicle operations. Then we'll explain what you need to do to maneuver safely out of a potential rollover situation. As the driver, you are responsible for your vehicle from the time you climb into the cab to answer a call until the time you return to the station. Your training, your experience, your physical conditioning, and your mental frame of mind all have an impact on how you handle your vehicle. Proper driver training is critical to knowing how to operate your vehicle safely. Unfortunately, most driver training programs don't go into a lot of detail about potential rollover situations. But if you drive a tanker or any emergency vehicle with a high center of gravity, you need to know advanced driving techniques, and you need to know how to use them so you can stay out of trouble when you're on the road. The physical and mental demands in this business are tough, so you better be able to meet those challenges. If you stay in shape and can keep a cool head when chaos is breaking out all around you, you're a good candidate to take the wheel of an emergency service vehicle. There's also a hidden factor you need to be aware of: the impact of adrenaline. You know yourself that when a call comes in, the adrenaline kicks on, and blaring sirens, flashing lights, and people yelling all drive that adrenaline higher. Do your best to keep your adrenaline under control so you don't overreact when you're driving and send your vehicle into a rollover. The best advice? Know yourself, know your strengths, and your limitations. Emergency vehicles are getting heavier and higher. Years ago, these types of vehicles would weigh in around 10 tons. Now they're topping off around 20 tons or more. Why the dramatic weight increase? To meet the demand to carry more equipment, more people, and in the case of pumpers and tankers, more water. Now, to carry more, we had to make emergency service vehicles bigger. But these vehicles can only be as wide as the traffic lanes they move through. So, since we couldn't go out, we had to go up. We used to build vehicles to a height of 8 feet. Now it's not unusual to see them at 10 feet, and aerial pieces are even a little more, 12 to 14 feet. Here's why height is significant. The higher the vehicle, the higher the center of gravity. The higher the center of gravity, the more unstable a vehicle is. The more unstable a vehicle is, the more difficult it is to control. Remember these concepts. We're going to come back to them later. The vehicle's suspension is also important in how a vehicle handles the road and how it carries weight. A weekly visual inspection of your vehicle will tell you if the suspension is intact and operational or not. This is possibly the most important part of your vehicle, your seat belt. Make sure you have it on before you pull out of the station. If you don't wear it, you could be putting yourself, your passengers, and others at risk if your vehicle rolls over. Know yourself. Know your vehicle, its height and weight characteristics, how it handles in both emergency and non-emergency situations, how it handles on highways and rural roads, and finally, wear a seatbelt. We can't emphasize that enough. Now let's take a look at this. What you're about to see is a tanker rollover. This tanker, filled with thousands of gallons of water, is traveling down a straight road and heads into a curve. The posted speed is 45 miles per hour, about the speed the driver is doing. But as you'll see, it's too fast for the road conditions. As the vehicle enters the curve, the driver slows down, causing the water load inside to shift to the front of the vehicle. At the same time, the vehicle leaves the pavement and the tires drop off a few inches onto the soft shoulder. The driver immediately yanks the wheel hard to the left to get the tanker back on the road. But the tire change from a hard surface to a soft surface, the weight load shifting inside the tanker, and the driver's excessive relative speed caused the vehicle to shoot across the road and go off the left shoulder. When the driver frantically overcorrects back to the right, the unstable vehicle rolls over and ends up on its side. Now we'll tell you about each of the factors involved in a typical rollover crash. Later, we'll come back to this scenario and show you how it could have been prevented. In this segment, we're going to take a look at the 3 most common reasons rollovers occur. They are traveling at an excessive relative speed into a corner or a curve. Excessive relative speed is the vehicle speed measured at any miles per hour which is considered unsafe in relationship to the operating environment, road conditions, or the vehicle. The other factors are soft shoulder drop-off and uneven surface drop-off and improper recovery. To help explain these rollover conditions, we're going to turn to an expert. His name is Herb Kaufman. Herb is a former fire chief who now works as a Pennsylvania certified state instructor. He's also an automotive and aerospace engineer for the Society of Automotive Engineers, or SAE International.
We may, as drivers, be looking too far down the road. We may not be anticipating the curvature of the road. It may be a road that we aren't familiar with. And so we enter the curve at a much higher speed than we safely should. That causes the driver to oversteer, maybe overcorrect as you enter the curve, and overcorrecting for it could cause the vehicle to swerve and roll over. One of the situations that creates that rollover scenario is dropping off on the right shoulder, typically the soft shoulder of the road. With so many of our departments running in undeveloped areas of the country, the berms of the roads are not properly maintained and may have no pavement at all. So dropping from a paved highway onto a soft shoulder at highway speeds creates a very dangerous situation. Once the vehicle has dropped off the edge of the road, then the driver may even jerk the wheel to the left to pull the vehicle back on the road quickly, throwing it into a situation where it swerves across the road and may not roll over until it actually crosses the highway and drops off the berm on the other side, or hits a curb, or runs into oncoming traffic. But that instantaneous quick reaction by the driver to overcorrect will cause the vehicle again to throw it out of control.
At the beginning of this presentation, we told you that a majority of rollover crashes are caused by driver error. Those errors occur because many drivers don't understand the laws of physical science and how those laws affect how a vehicle will handle under certain conditions. So let's review some of those physical dynamics that you probably learned in your sophomore physics class. The law of inertia states that an object in motion will stay in motion along a straight line unless it is acted upon by an unbalanced force. Momentum refers to the weight of the object in motion combined with the speed or velocity at which it is traveling. The height, weight, and width of your vehicle combined with your speed will produce a momentum that you must be able to keep under control when you're out on the road. The center of gravity on a vehicle is the place measured from the ground up where the weight will be equally balanced.
As if you took that vehicle and suspended it from a string, the pivot point, the horizontal axis of where that vehicle would pivot, is what we call the center of gravity. Every time you add weight to the top of the vehicle, whether it's hose or water or equipment, you move the center of gravity up away from the highway. If you think about a race car, race cars tend to be wider and lower, and that's to keep the center of gravity low, to keep them from sliding or even flipping over.
Friction, for our purposes, refers to the tire patch or the footprint of the tire to the road. The footprint of one tire is about the size of an 8.5 by 11-inch piece of paper. If you drive a single-axle vehicle, you have only 6 tire footprints keeping your vehicle on the road at all times.
That small amount of tire contacting the road is very, very small compared to the size of a vehicle, which may be 30 feet long, 10 foot high, and may weigh between 35 and 40,000 pounds. When you put all those factors together, it really makes you think about how that vehicle is going to handle to keep those 6 small pieces of tire in contact with the ground continuously.
Centrifugal force is defined as the force caused by inertia which makes a rotating body move away from the center of rotation.
Sharp curves present a unique set of problems, but broad, long, sweeping curves that you might find on a 4-lane highway or interstate highway cause problems as well. You need to, just as in a sharp curve, decelerate into the curve, then accelerate and steer out of the curve. All the while you're doing this, all the while the vehicle is moving through a broad sweeping curve, remember that the centrifugal force, the shift in the load of the water or what have you, is pushing that vehicle to the outer edge of the curve. Now you may be able to maintain the lane that you're traveling in, but at some point, because of the long, broad sweeping nature of the curve, you may lose your friction characteristics, or the road surface may change and actually start to slide. The body rolls and the vehicle shifts from side to side.
Okay, now that you have a grasp on some of the physical laws that control moving objects, we're going to apply those laws to your vehicle and tell you how it will react in specific conditions. We'll start with one that shouldn't surprise you: speed, driving too fast. NIOSH and the USFA have both determined in different studies that excessive relative speed is a common factor in most rollover crashes. The key word here is relative, which we told you a few minutes ago means your speed in relationship to your environment or road conditions or your vehicle.
Based on the conditions, the speed you travel today on a dry road may be much different than the speed you travel that same road tomorrow when it's wet or snow covered. It's important for drivers to understand that this friction between the tire and the pavement is greatly compromised by the addition of water to the road. In fact, the chart will show you that in some situations, the difference between dry asphalt and wet asphalt friction is compromised by 50% at speeds of only around 30 to 40 miles an hour. That's not a very high speed to have your friction coefficient drop by 1/2.
Bottom line, maintain a slow, steady, safe speed. It's true, there may be people injured on the call who need you urgently, but before you can help them, you need to arrive safely. You may not realize it, but different road designs will also impact your ability to handle your vehicle. We'll just concern ourselves with the 4 designs that affect rollover potential: high center crown, reverse or negative camber, S-curves, and restrictions of lane width.
Drivers also have to consider the construction of the road and what we call the crowning of the road. In rural areas, roads have a high center and low edges in order for the water to drain off. In fact, most roads have that, but particularly in rural roads, it's much more pronounced. That negative camber causes the vehicle, as it's traveling even down a straight road, to tend to want to move towards the berm. So you're always fighting the wheel, even if it's ever so slightly, to keep that vehicle on the road.
S-curves are a problem for vehicles with a high center of gravity, especially if the driver's traveling at a high rate of speed. The winding structure of an S-curve forces a vehicle to shift its weight from side to side, which creates a rolling effect. Excessive relative speed, combined with body roll, could easily lead the operator to lose control and end up in a rollover situation. We probably don't think too much about how the restrictions of lane width can affect our driving, but in certain situations, it's a critical factor.
The design of today's vehicles, particularly their width, works very well on a 4-lane expressway with wide lanes and gradual turns. When you take that same vehicle to a city street or a suburban highway or a country road, most of that lane width is taken up by the vehicle itself. So the ability of the driver to correct a situation where the vehicle gets out of control is greatly hampered by the oversized vehicle on the smaller road.
Now we'll take a look at the combination of effects that body roll, center of gravity, and tire sidewall flexibility can have on your ability to handle your vehicle.
When you add up the number of factors of a vehicle moving down the highway, the tendency of the vehicle is to roll from side to side. Now on a straight highway, that's minimal. You hardly detect it at all. But because of curves and water slosh, shift in the load, possibly, the body will tend to what we call roll. In other words, it pivots around that center of gravity. If you think about the center of gravity being a bullseye in the target, it'll pivot from side to side. In entering a curve, if your speed is too high, that body will want to roll from side to side. And you need to be careful that you keep the body roll to a minimum. If you think about the water sloshing inside the tank, the roll will go one direction because we've gone through a curve, and then either because of correction or because maybe an S-curve that you're going into, it'll go the other direction. That water will start to slosh back and forth and cause the body to roll even though you think you've maintained a straight line control of the vehicle.
What's happening is the body is actually pivoting around the center of gravity. You have the picture? We're entering a curve. The body begins to roll as the center of gravity keeps changing. As the driver, things are starting to get out of control. Now we add another element, tire sidewall flexibility.
There is a factor with today's radial tires where the tires are designed to have flexibility in the sidewall. That helps maintain that footprint on the pavement as you safely get on the road through curves. The tire will actually flex from side to side. That's a good thing. In an uncontrollable situation, that flex may become too great, and as that tire flexes from side to side, the weight of the vehicle is thrown into a situation where the entire vehicle could roll over. So on one hand, you have a very safe situation and radial tires that are safe as the vehicle is traveling down the highway. In another situation where the vehicle begins to lose control, they actually contribute to the weight shift.
We tend to think of body rolling and weight shifting being a problem only with tankers and pumper tankers, where the load is in constant motion. But ambulances carry moving loads too.
In the back of an ambulance, you have maybe 2 or 3 medics moving around, working on a patient, standing up, moving the weight around in the back. So while you may think that that's more of what we call a static load in the back, where everyone's seated and in place, just that movement of 1 or 2 medics walking around, moving from side to side, standing, will create different dynamics that the driver needs to be aware of and control. Again, speed is a major contributor to how that body roll or how those dynamics of the weight shifting affect the ability to control that vehicle.
We said earlier, you need to know how your vehicle handles in emergency and non-emergency situations. When you know how your vehicle operates with constant weight shifts, you'll be able to steer and brake safely in and out of curves and over uneven surfaces during a real call.
When the vehicle is entering a curve or even on a straight highway, braking and deceleration also have a huge effect on weight transfer. If you're thinking about a situation where the vehicle is entering the curve and the vehicle is sitting horizontal, as it enters the curve and as the driver brakes, it actually dips to one side. If it dips on a left to right hand curve, if it dips to the right front wheel, the back wheels in essence start to come off the ground. They may not totally leave the ground, but that weight distribution and body roll causes the friction on the left rear wheels to become much less. If you overcompensate, oversteer in that situation, that's where you throw the vehicle out of control.
We talked earlier about tire friction and about how 6 patches of rubber, if you're driving a single-axle vehicle, are all that's holding you to the road at any given time. So you can imagine, for example, if you drop off onto a soft shoulder at an excessive relative rate of speed, that friction will be severely compromised. Then, when you try to steer back onto the hard road surface, you'll face a tough challenge. To compensate for the difference in height between the road surface and the soft shoulder, you'll need to apply a greater angle of steering to overcome the resistance of the road surface against the tires of your vehicle. The last category related to mechanics that we want to talk about involves what's called the liquid slosh effect. If you drive an emergency vehicle that carries water, you need to know this.
The solid loads tend to be steady, more controllable. You can hold them in place. Liquid loads move about as you're going down the highway. They move side to side as you're going through curves. They'll move front to back as you're accelerating and braking. So you have this liquid in constant motion. We all have heard about baffling being installed inside tanks to minimize that water slosh, we call it, but it still occurs. Also a dangerous situation in the load factor is the idea that you may only have a half a load of water in there. Ideally, a fire apparatus would either be totally full or it would be empty, but for some reason you may only have a half a load of water, and that slosh effect is dramatically increased by only half a load.
That slosh effect is going to shift the center of gravity in your vehicle. If you're traveling at an excessive relative rate of speed entering a curve, this weight transfer will make your vehicle roll and really impede your ability to keep your vehicle on the road. Now that you've sat through an explanation of all the physical and mechanical factors that have an impact on rollover crashes, you're probably thinking, okay, I've got all that. But what do I do if I feel myself losing control of the vehicle? Follow these steps. First, do not panic. Panic will put you in a very bad situation very quickly. Every situation will require a different reaction, but generally, keep these practices in mind. Get control of your speed. Take your foot off the accelerator and allow the vehicle to slow down gradually. If the vehicle's still traveling too fast, you can softly depress the brakes and downshift to bring the vehicle to a safe speed or a complete stop.
Dropping from a paved highway onto a soft shoulder at highway speeds creates a very dangerous situation. The way that should be handled is maintain control of the steering wheel and steer straight ahead and slow down. Take your foot off the accelerator, but do not touch the brake. Allow the vehicle to slow on its own. Once you've reached a slow, safe speed, then very carefully turn the wheel to the left and pull the vehicle back onto the highway. Then you can accelerate after that. Do not jerk the wheel. Jerking the wheel to the left or right causes body roll, immediately shift in weight, and could cause the vehicle to roll over in an instant. Keep in mind to maintain your speed, decelerate properly, keep your wheel under control, no jerky motions left or right.
And never attempt to steer back onto the road surface at speed or under acceleration. Gain control of the vehicle first. Then gently steer the vehicle back onto the road using a lower gear or feathered acceleration to get up and over the surface drop-off. Now we're going to go back to the scenario we showed you earlier. Only this time, the driver will use the methods we just described to regain control of his vehicle and get back to the road safely. The heavily loaded tanker is traveling down a straight road and heads into a curve. The posted speed is 45 miles per hour, about the speed the driver's doing. As the vehicle enters the curve, the driver brakes, causing the water load inside to shift to the front of the vehicle. At the same time, the vehicle leaves the pavement and the tires drop off a few inches onto the soft shoulder. This time, the driver is prepared. He maintains firm control of the wheel and keeps the vehicle going in the same direction. He takes his foot off of the accelerator and allows the vehicle to slow gradually. He doesn't jerk the wheel or use the brake. Then, when the vehicle has coasted to a safe speed, the driver turns the wheels to the left to bring the vehicle back onto the road. Crisis averted. It's easy to understand what to do, but it's a lot different to have to actually do it in an emergency situation. That's why rollover training is critical for all emergency service drivers. And we've said it before, but we'll say it again. Wear your seatbelt, on the job and off. Don't think about it, do it.
One thing that has always been in my mind mandatory for a driver and all passengers in a vehicle is the use of seatbelts. Seatbelts not only prevent injury in case of an accident, they'll also keep the driver in position so they can maintain control of the vehicle. If the vehicle happens to get out of control or happens to be hit by another vehicle, the forces inside will throw that driver around and they'll lose contact with the wheel or with the brake pedal in certain situations. It's important that that seatbelt hold them into place.
Remember, it's always a combination of factors involving the laws of physics, the mechanics of vehicle operation, and operator error that gets drivers into trouble when they're hurrying to a call.
Once we're called upon as firefighters and EMS personnel, our job is to get to the incident, handle it, save lives, save property. If on the way to that incident we're involved in a crash, then we become part of the incident and we can't help the people that we've been called upon to help. So it's our job to keep ourselves safe first and then help others.
Play it safe. Get the proper driver training on preventing a rollover. And when you're out on the road, slow down and wear a seatbelt. We want you to live to serve another day.